Hello again. In this lecture, we'll be talking about the Elementwise properties of arrays and how they work. As always, we'll start by defining the variables we intend to use. In this case, they are a 1D array called array A and a 2D array called array B. So, Elementwise means that whatever mathematical computation we are conducting, we are doing it to each element of the array. For example, let's add 2 to our 1D array. As we execute this cell, we see that in every position in the new array, we have a number which is 2 greater than its corresponding individual element of the initial array. Hence, 7, 8, and 9 are now 9, 10, and 11. This works the exact same way for arrays of higher dimension too. We can check that by using the 2D variable array B. Great! What's more, these properties hold true for other operations like subtraction and multiplication. We understand that if you're used to working with lists, seeing operations like addition and multiplication work element-wise might feel counterintuitive. However, this is because lists and arrays serve different purposes. To elaborate, the main purpose for lists is to store data. So it makes sense that if we add a number to a list, the list will keep all of its current values and simply attach the new one to its end. Contrary to that, the main purpose of arrays is to compute mathematical operations. So the same operation will alter the value of each element in the array without changing its shape or size. Additionally, we can work with arrays of the same shape. To test this out, let's find the sum of the 1D array, array A, and the first row of the 2D array, array B. The result is another array of size 3, where the first element is the sum of the first elements of the 2 arrays we're using. The second element is the sum of the second-placed values, and so on. Hence, each individual element is added up with its corresponding counterpart from the other array. This phenomenon is called elementwise addition. For the remainder of the course, we'll refer to any functions or methods as elementwise if they comply with the elementwise properties of ND arrays, like addition. Of course, we can test this out with the second row of the array B by changing the index within squared brackets from 0 to 1. Once again, the output is the sum of the numbers in corresponding positions across the 2 arrays. As was the case with simple numbers from earlier, we can conduct other elementwise operations like subtraction or multiplication, and they will work exactly as we would expect. Did you know that we can also conduct operations between arrays of different dimensions? Let's try this out. First, remember that the shapes of the arrays need to be compatible. In other words, the length of the 1D array must match the length of the 2D array. Lucky for us, that's exactly the case with arrays A and B. So let's see how this works. Simply type array A plus array B and run the cell. The output suggests we've added the 1D array to each row of the initial 2D array. If we now switch the plus sign with a multiplication sign, we'll see the same trend continue. We're conducting elementwise multiplication between the array A and each row of array B. Great! Once again, you can remember that we can do this for other operations as well. Just don't forget that for operations like subtraction or division, the order in which we write the arrays is important. For example, if we subtract array B from array A, we get positive values, since the values in array A, which are 7, 8, and 9, are greater than any of the values in array B. However, if we switch the order and subtract A from B, we'll get an array with only negative values. That's why you need to be careful when using subtraction or division. Fantastic! Now that you've grasped the concept of elementwise properties and operations, it's time to move on to the data types. In the next lecture, we'll discuss what kind of data NumPy works with and explain what native data type objects are. Thanks for watching!